Okay, so solving exponential and log equations. Right, now then, the difference between doing something like this, 4 to the x equals 16, is that, well, for one thing, I know that x is 2, but you could say that 4 to the x equals 4 to the 2. In other words, you can write both of these with the same base, okay, and therefore x must be 2. So once you've got the same base, the exponent can equal the exponent. But of course, something like this down here is a different kind of problem because, of course, I can't write 17 with a base of 4 or a base of 2 or whatever it is. Okay, so they're different kind of problems. So let's take a look at this first set. As long as we have the same base, the exponent equals the exponent. Well, look at this. This both has a base of 2. So I don't do anything. It's just 3 minus 6x equals 9 plus x. Exponent equals exponent. And then just solve for x. So that's straightforward. Okay, now the next one. Okay, this has a base of 4. It could also be a base of 2. And it's got 9 minus 3x as an exponent. Now 64 can be a base of 4. And of course 64 is 4 cubed. So therefore, because we have the same base, then 9 minus 3x equals 3. And you just solve for x. Okay? Right, let's take a look at this one. These are kind of good ones. So again, a 2, a 4, and a 16 all have a base of 2. Okay? So 16 is 2 to the power 4. 4 is 2 to the power 2. This already is a base of 2, and it has a 5x. Now, this is the thing about these questions. Once you see two bases, the same bases being multiplied, remember you add exponents. In other words, this should be written as 2 to the 4 equals 2 to the 2 plus 5x. Remember, I am just adding these two exponents because we're multiplying two things of the same base. And again, so because you have the same base, 4 equals 2 plus 5x, and you just solve for x. That's how it works. Okay. Now, let's have a look at more of these. Let's have a look. Well, how about something like this one here? Of course, if I think of this as base 2, then what you've got here is, that's straightforward on the right-hand side. It's already got the base of 2. Oh, interesting, because 8 is also 2 cubed. But here's the thing. Remember when you see fractions, remember you're going to get negative exponents. A 1/4 is the same as 1 as 2 squared, which is the same as 2 to the negative 2. With a base of 2, it's a negative 2 exponent. Okay? Now, I've also got the, negative 2. Of course, I've also got the 3x up there as well. Okay, so what I actually have here is this. 2 to the negative 6x, because remember, this is 2 to the negative 2, and this is already there, times 2 cubed equals 2 cubed. Now, the point is, you could probably cancel both those 8s. But if it wasn't an 8, you wouldn't do, okay? You could reduce some of this. But you could also say this. I've got a base of 2. Because these are being multiplied, I would add exponents, okay? So, negative 6x plus 3 equals 3. Exponent equals exponent. And you solve for x. But can you see that's going to be 0 anyway, okay? Right. So that's just remembering that when you've got fractions, remember, negative exponents. Okay. Now, the way to do this next set, there's just one specific way to do this. Well, I prefer to do it. You can do it actually by change of base rule. So one way, I'll do it both ways. I'll do it one way, and I'll do it the way that I usually show. But sometimes students realise that this here, if I change it to its log form, that is log to base 4 of 17 equals x. I can now use the change of base rule and say that x equals log 17 over log 4, with, or ln 17 over ln 4. Remember, this is the log base 10. So you could do that, okay? But when it gets a little more complicated, I like to think of log both sides, okay? So log both sides. In other words, if I write log of 4 to the x equals log of 17, I've just logged both sides, okay? The reason is remember, this exponent can come through the front. So it becomes x log 4 equals log 17. These are just numbers. If you divide by the number next to the letter, Remember, that's what we got last time anyway, okay? So log 17 over log 4. So, all of these. So again with something like this one, you know, I would log the 3 to the x minus 6. I would log the 1. Now, actually, the log of 1 is 0, so I could make life a little bit easier. But the reason why we did this is the x minus 6 can come to the front. Okay. Now, there's different ways of doing this. Some of the books say do the distributive law with the log 3. In other words, you'd have x log 3 minus 6 log 3 equals log 1. Okay, that's just me doing the distributive law on the left-hand side. But actually, you could also do it as basic as this. Just divide both sides right now by log 3. Okay, so x minus 6 equals log 1 over log 3, and then can you see just add a 6 to both sides. So basically that would be the answer as well. You put it in your calculator. Okay. Now do beware of some shortcuts. I'm going to show you shortcuts. Well, let's take a look at this one here. First of all, I don't have the base by itself. The base here is the e. The 10 is just something that's been multiplied by, so I'm going to divide both sides by 10. I have e to the 3x equals a half. 5 over 10 is 0.5. Okay. So now if I log both sides, okay, if I log both sides, I'm going to have, now use ln here. The point is to use ln of e to the 3x equals ln of 0.5. Because the base is e, use natural log. Now, the whole idea behind that is, if you remember this rule, if the base is the same as this, the answer is just the exponent. So because natural log is base e, the answer here is just 3x. That's still log of a half. Divide both sides by the 3, and then that is your answer. Okay. Right, let's take a look at some more of these. So again with something like this, you know, you would, oh, here we go, here's one. E to the 3x is going to equal negative 1. Okay, now that's not going to work for one thing, you can't log negative 1. Okay, can't log a negative, so that's actually no solution. This one here, you would add a 13, so that's going to be negative 10. But it's okay, because I'm going to divide by negative 2. I will have 10 to the x plus 15 equals 5. Okay? So again, this is just log both sides, but this time use the word log because that's base 10, this is 10, that's x plus 15, that is log 5. Okay, I've logged both sides. Remember, if these are the same, the answer is just x plus 15 equals log 5. And then take away 15 from both sides. Okay, so a couple of shortcuts when you've got a base of 10 and a base of e. Okay, you can bring the exponent, well, you don't bring the exponent to the front, the answer is just the exponent. So again, just remember, I'll write it again, that rule, when the base, same as that, the answer is just the exponent. Okay? Right, some of these are actually harder ones. I think I'll actually just, I'm going to actually stop there actually, and go on to another video.